Hello, this is Ms. DB, and in this video we are going to continue our Chapter 4, Section 3 lesson on using matrices to transform geometric figures. In this lesson we'll talk about how to reflect and rotate a figure. A reflection matrix is a matrix that creates a mirror image by reflecting each vertex over a specified line of symmetry. So we are going to be working just with reflecting over the y-axis or reflecting over the x-axis. Although reflecting over the line y equals x is not bad either. So to reflect across the y-axis, we will multiply -1, 0, 0, 1, this 2 by 2 matrix, by the coordinate matrix. What happens when we do that is all the x-coordinates will be reversed and the y-coordinates will be the same. So remember that matrix multiplication is not commutative. You can't multiply in any order. The transformation matrix has to be on the left. Also remember that you can double check if you're not sure how the x and y coordinates are going to change after this multiplication, but you can check with the online matrix calculator, or you can use a graphing calculator to double check your matrix multiplication. Alright, so here's how you do it. If you're going to reflect a figure, this is triangle PQR, then you have to write the reflection matrix first. They want to reflect across the y-axis, which is the same as this one was given. So that's -1, 0, 0, 1. That gets written down first. Then you write your pre-image matrix, your PQR. So this is the matrix, the coordinate matrix for PQR with, remember, the x-coordinates on the top and the y-coordinates on the bottom, and then you multiply. Now, when you multiply matrices, remember that you take everything in the first row times the first column of the second matrix. So you'd go -1 times 2 plus 0, -1 times 2 plus 0 times 2, and that equals -2. And then you take, let me move this over. Then you take -1, 0, that row, times 2, -1. But the zeros help out a lot with this. So you'd have I'll do it this way, -1 times 2 plus 0 times -1. 0 times anything is 0. So it's really just the -1 times 2, which is -2. Then we move over to the third column, and it would be -1 times 4 plus 0 times 3. So that's -4. So you see that all of the x-coordinates change to the negatives. Now when we do the y-coordinate down below, we multiply by the second row. In the first column, we'll get 0, 1, and we'll multiply by 2, 2. So we'd have 0 times 2 plus 1 times 2. Well, that's 0, and that's just the 2. And then we'll move over to the next column. And again, these zeros help out a lot. We'll have 0 times 2 plus 1 times -1. That's just -1. And then finally, you'd have 0 times 4. That's just 0 again. Plus 1 times 3 is 3. So this is our A, or it's not A, is it? It's P. P prime, Q prime, R prime. And then they'll probably ask you to graph, and they'll ask you to write your coordinates of your image, and here they are. And this is what the graph would look like. Okay, if you're reflecting about the x-axis, then you use 1, 0, 0, -1. So again, that has to be written first. And then you write your pre-image, and then you multiply. So 1, 0 times 3, 4, this row times this column is just going to be 3 because of the zeros. And then this will be 4 and this will be 1. So the x-coordinates will all stay the same. When you move to the second row, it's 0, -1. So 0 times 3 is 0. -1 times 4 is -4. So what's going to happen is you're going to get the opposite sign for each of the y-coordinates. And then you will graph it, and you will write the coordinates of the image after the transformation. In your worksheet, in your assignment, the graph of ABC is already here. It's got these vertices, negative 2, 1, B is negative 1, 4, and C is 2, 2. And we want to reflect about the x-axis and about the y-axis. So you might have to look back in your worksheet, but the x-axis was 1, 0, 0, negative 1, 1, 0, 0, negative 1. And the reflecting about the y-axis was negative 1, 0, 0, 1. Negative 1, 0, 0, 1. And then you put your pre-image matrix. Remember, the x-coordinates go on the top and the y-coordinates go on the bottom. 2, 2. And that will be the same for this one. And then you do your multiplication. And you have a lot of zeros when you multiply, so it won't be bad at all. And if you want to double check your multiplication, then you can use the online matrix calculator or use your graphing calculator. But when you reflect about the x-axis, oh, I think I might have switched these two around. Let me go back for a second. This one's the x-axis. I did switch them around. So this one would be 1, 0, 0, negative 1. And this one is negative 1, 0 for the y-axis. So the y-axis is all the x-coordinates will have their signs changed, and the reflecting about the x-axis, the y-coordinate signs will change. Here's one where you have, it says use matrices to reflect the figure with coordinates A, B, C, D, E across the x-axis. So going across the x-axis, you use the matrix 1, 0, 0, negative 1. 1, 0, 0, negative 1. And you multiply that by the pre-image. And then after you do your multiplication, you will have your image. So this is our coordinates of A, B, C, D, E. You don't have to draw this one. You can just write the coordinates when you're done. So on this one, when you take your first row by your first column, you will get 1 times negative 2 plus 0. And then when you move over to the next one, you'll have 1 times 0 plus 0. And then when you move to the next row, you'll have 1 times 2 plus 0. So you'll see that you're just going to be taking the same sign of each of these once you multiply. And then you'll have 1 times 2 plus 0. And then 1 times negative 1 plus 0. So the x-coordinates all stayed exactly the same. When you move to the y-coordinates, however, then you have 0 times negative 2, that's 0, plus negative 1 times 3. So all of these ones are going to be multiplied by negative 3. And you're adding to 0 because 0 plus 0, negative 1 times 4. So you're going to be taking the opposite sign of each of these. And then for your final answer, then write what A prime is equal to. It'll be negative 2, negative 3. Write what B prime is equal to. That would be 0, negative 4, and so on. All right, next we're going to talk about rotation matrices. A rotation matrix is used to rotate a figure. So it's kind of like what we do with the reflection. We're going to be multiplying. We take our rotation matrix and then we multiply our pre-image matrix by that. So there's different ones for rotating by a different amount. So if you want to, and of course you could rotate by degrees other than 90 or multiples of 90, but those are more complex matrices and you have to use trigonometry to do it. So we're just going to be multiplying by these ones first. So multiplying by 90 degrees counterclockwise, and it's important that you read if it's counterclockwise or clockwise, is 0, negative 1, 1, 0. If you want to multiply counterclockwise, sorry, I said that wrong. If you want to rotate counterclockwise 180 degrees, then that's negative 1, 0, 0, negative 1. And if you want to rotate counterclockwise 270, which is also the same as rotating clockwise, 90. Those will end up being the same. You can check. Then you multiply by 0, 1, negative 1, 0. So each of these, it's going to be very similar to doing a reflection, is that you have to multiply on the left has to be the rotation matrix. So on this example, we're going to rotate polygon ABCD with these coordinates about the origin. So the first one, 0, negative 1, 1, 0, this is rotating 90 degrees counterclockwise. And B is going to be, this is the either clockwise 90 or counterclockwise 270 from the page right before. They're going to ask you to describe that when you're done. So in A, when you multiply, you will get, look at what happens. Doing this multiplication, this first time, oops, I circled the wrong. This row by this column, 0 times 0 is 0, negative 1 plus 1 is negative 1. Basically, you're taking you're flip-flopping where these two rows go, but you're also taking the opposite sign of the bottom one. You don't have to remember that because doing the multiplication will get you there. And then my first row by my next column will be 0 times 2 is 0, plus negative 1 times negative 4 is a positive 4. And then your next column, 0 times 5 is 0, negative 1 plus 1 is negative 1, and then 0 times 2 is 0, plus negative 1 times 3 is negative 3. Now in the next one, when you multiply by 1, 0, nothing changes. So if you're ever taking the row 1, 0 and you're multiplying by these columns, these numbers will remain the same. So 1 times 0 is 1, plus 0 times 1 is 0. So 1 times 0 is 1. 1 times 0 is 0, plus 0. And then 1 times 2 is 2, plus 0. Whoa. So that's the 2. So you can see this row is, the numbers from the top row are coming down here. And then 1 times 5 is 5, plus 0. And then 1 times 2 is 2, plus 0. So this is A prime, B prime, C prime, D prime after a rotation 90 degrees counterclockwise. The second one, we write our pre-image after a rotation matrix, and then you multiply. And when you multiply, you will get the following matrix, this image. And if you graph these on a graphing calculator or in Sketchpad or just on your own paper, you will see that this now has been rotated 90 degrees clockwise, which is the same as 270 counterclockwise. Here is our result. So the first one was the quadrilateral, the polygon, the blue one, the pre-image. In this top one here, this purple one up here, this was rotated 90 degrees counterclockwise. The other one is rotated 90 degrees the other way, or you could say it's rotated 270. So here's 90, 180, 270. If you go 360, the matrix for 360 would be 1001, the identity matrix, because you'd end up with the exact same thing. Here's some problems from your worksheet. It says to rotate this triangle, first 90 degrees counterclockwise. So you need to look up what the rotation matrix is for that. And then you put your pre-image matrix over here, the coordinate matrix, 2, 2, and then your results over here. So let's see, we would have 0 times negative 2 is 0, plus 1 times negative 1 is negative 1. And then we'd move over to the second column and still use the first row. So 0 times -1 is 0, plus -1 times 4 is -4. And then we would have 0 times 2 is 0, plus -1 times 2 is -2. So our top row would be -1, -4, -2. And then for our bottom row, we will switch to using our second row by each of these. So 1 times -2 is -2 plus 0, that's -2. And then 1 times -1 is -1 plus 0. And then 1 times 2 plus 0. So after rotation 90 degrees counterclockwise, A prime, let's see, will be at -1, -2. There's A prime. B prime will be at -4, -1. And C prime will be at -2, 2. So if we connect these points, whoa, that one got wavery. That is our triangle after rotation 90 degrees about the origin. And then you can find out what for number 6 and number 7 it would look like. So A prime is at -1, -2, B prime was at -4, -1, and C prime was at -2, 2. It doesn't say that you have to graph these. If you can, go ahead just to see what it looks like for yourself, but otherwise you don't have to. And you don't actually have to describe the transformation because we did that right here. That was the describing the transformations. One more problem to look at before we close for the day. This says to use matrices to rotate the figure with coordinates K, L, M 90 degrees counterclockwise. Find the coordinates of this vertice of the image. So I pasted in what the transformation matrix would be in order to rotate counterclockwise 90 degrees, and then you multiply this by KLM. This is exactly the same as the one we just did. And you would find out what you get. You don't have to sketch it unless you want to, but you need to, when you're done, write what you got for each of your image coordinates. All right, well, thank you very much and have a wonderful day. Please let me know if you have any questions or if you get stuck on any of these. Thank you.